So in our last class, what we had discussed about the services, we had discussed about the rollbacks, right? Rollbacks, rolling updates, recreate, and upgrade, how this happens in the Kubernetes and what will be the benefits of using it, right? We had all discussed it. So services is the most important part to communicate within and outside the pod and the cluster. Okay, so today we'll talk about the storage of the data, right? Pod data or the container data, the application data. That is most important carries to remember the persistent volume. Okay, the persistent volume. So first, using the persistent volume, we need to understand what exactly the persistent volume is and how we can use it. Okay, so the persistent volume claim, right? Before using the persistent volume claim, we should know about the persistent volume. Should know about the persistent volumes or persistent volume, we can say. So Docker, we had seen in Docker class, right? We had seen creating the volumes, and then what we had seen, we created volume and attached to the container so that the container data will be persisted or stored. So why we need? Because the nature of the container is when the container gets exited or terminated, all the data terminated or deleted, all the data inside the container will be lost along with the container, right? So to persist the data, to storage the data, we need the volumes. So similarly in Kubernetes, we have the persistent volume concept where we can store the container data or the pod data so that we can use it for future reference or for the consistency of the data. So what it says, the data is destroyed along with the container. To persist data processed by the container, we need to attach a volume to container when they are created. That is what we do in the container classes, in the Docker classes, right? We need to attach the volume to the container so that data will be stored or persisted. Same thing also with pods. When a pod is deleted, the data processed by the pod also gets deleted. The same thing, right? We need to again attach a volume to the pod. The data generated by the pod now will be stored in the volume. So what is the persistent volume? A persistent volume is a cluster-wide pool of storage. It is a cluster-wide pool of storage. Whatever the cluster you have created, the persistent volume will be cluster-wide pool of storage volume configured by an administrator to be used by the user deploying application on the cluster. If you are a Kubernetes administrator, if you are a Kubernetes developer, then you don't have to manage all these things. Your administrator guys would have created the volume and you have to use it. If you are having both things, managing both admin work and development, then you must have to get ideas on the persistent volume, have to get work on the persistent volume, right? So it will be very simple, guys, to do the persistent volume. You have to simply just write the applications, write the configurations file or the manifest file with. So let's, I had already shown you, right, how to search that one, right? So if I just do Kubernetes, then search for here persistent volume. So you'll get the complete documentations of the persistent volume and how to write the configuration file, definition file, right? How to write the definitions file. Everything you will get it over here. And lots of other things also there. Okay, let me first explain you from this PPT and then we'll go to the documentations. So if you see this diagram over here, small image, what is each API version v1, kind is persistent volume. Kind is persistent volume, and specifications, you have to provide the access mode. How would you like to access the storage area, the volume? Read write once. Okay, I'll just explain you more on that in the persistent volume claim. Okay, so the capacity, how much you want to volume or storage you want to create it. The storage, suppose 1 gigabyte or 10 gigabyte or 100 gigabyte, up to your requirement, right? And then here you can see here it is created as AWS Elastic Block Storage. So Either you can locally store on the system, or you can use various storage system. So this is being used AWS storage, EVS, to store it. You can use Google's storage drive. You can use anything. Okay. So now, once you create it, so very simple, kubectl create definition file. That's all. It will create the volume. It's not about just remembering the command alone, guys. Command is just simple things to create and get informations about the pod and the objects in the Kubernetes. The most thing is to write the definition file, write the manifest file, and to understand how it works. That is most important. Okay. Now, so once we create the volume, how we'll attach that one? In Docker, what we used to do, we have to write while in the runtime, we have to specify the command in the runtime, and then it will attach, right? But here, we have to use the persistent volume claim. We have to use the persistent volume claim in order to claim the volumes, whatever we have created. So what it says, the administrator creates the persistent volume and the user creates the persistent volume claim. So once the administrator has already set up the volumes or created the storage area volumes, you need to access these areas, right? You need to have attached that to your pod, so that whenever the user or the developer just write the definition file, he has to specify how much volume our application or the pod need to be added. So suppose the pod, we have 10 gigabyte of volume, and our pod is required to be attached to that volume claim. So we need 10 gigabytes, so we can assign. So the volume will be created, specific volumes will be created by the administrator, and you have to just attach it by using the persistent volume claim. So once the persistent volume claims are created, Kubernetes binds the volume to the claim based on the request and properties set on the volume. Every claim is bound to a single volume, persistent volume. During bind process, Kubernetes tries to bind a PV that has sufficient capacity as requested by the claim. As requested by the claim. Suppose you have two volumes available. Just an example, okay? One is 10 gigabyte of volume, one is 20 gigabyte of volume. And you wrote the claim, the definition file, and you are claiming for 15 gigabyte of volume. So what it will do? So it will just go to the 20 gigabyte of volume based on your configurations you have set up, because it's require more specifications you have specified, right? So it will not go to the 10 gigabyte. But whatever you have specified, suppose you have specified in the claim, you have claimed like for 10 gigabyte, then 10 gigabyte will just bind to the 10 gigabyte of volume available. Okay. So if a multiple matches available, then we can still claim it using the labels and selectors. Suppose we have 10 gigabyte of volumes, 4 volumes available there. But which particular volumes you have to attach? That is most important, right? You cannot just attach like whatever is available. No, you have to attach based on the system, based on the applications you are working, and you know about what volume is required for you. If it is new, if the volumes are new, and if you're writing the new definitions file for a new application deployment, then you can go with the available volumes. Once the volume is attached, the same volume will be added to the same pod. How you have to identify and how you have to do specify, you have to do that using the labels and selectors. Okay, so here labels plays a major role by adding the PV to the claim, right? Sorry, to the claim to the PV. If there is no matching PV available, then PVC, like the claim, will claim whatever PV available. In the below, see what we have. Let's do that. As I was just explaining, right? We need 500 megabyte MB of if we have 1 GB available, then it will claim 1 GB. As I was telling, if we require 15 gigabyte, but we have 20 gigabyte available, then it will attach to the 20 gigabytes. Okay, so there are 3 access modes available: read only, many, read write once, read write many. These are the access modes available. Okay, so these are the things and basics about the persistent volume. Let's go to the documentations and see how it is and what are the more things available. See, whatever it says, a persistent volume is a piece of storage in the cluster that has been provisioned by an administrator or dynamically provisioned using the storage classes. Okay, so the claim is whatever the volume we create is a request for the storage by the user, right? So while persistent volume allows a user to consume abstract storage resources, it is common that users need persistent volumes with varying properties such as performance for different problems and all these things. You need to see first what kind of volumes are available with all the specifications you have. And based on that, you have to choose whatever the volumes is suitable for your deployment, right? So let's see the life cycle of the volume and the claim. So here, provisioning. First, we have to provision, right? The administrator has to provision that. There are 2 ways of PV, maybe provision statically and dynamically. Statically is a cluster administrator creates number of PVs. They carry the details of the real storage which is available for the cluster user. But in case of dynamic, when none of the static PVs administrator created match a user's persistent volume claim, the cluster may try to dynamically provision a volume specifically for that PVC. If there is no volumes available, if you have specified in the configurations, then dynamically Kubernetes will create one. Okay, so that is what, okay, to enable the dynamic storage provisioning based on storage, the cluster administrator, then administrator has to do the setups in the administration controller or the master. Okay, and binding, what is the life cycle? First provisioning, remember, first provisioning, then binding, using it. So once the binding happens, binding will happen automatically once you wrote your persistent volume claim definition file. It will automatically bind. And then once the bind happens, the pod will start using it, right? Now, storage object in use protections. We were talking about the access modes, a type of access, whatever the thing access available that we can use it. And here, see how we have to do this. We have to use the labels, right? You can see here labels and all. We'll see in details. Wait. Okay. Here is the reclaiming. Whatever the PV available, you have to reclaim it. If reclaiming means, see, whatever already you have claimed it and you deleted the pod and you created the same application, redeployed it. Then you have to reclaim the existing volume for that application, right? So when a user is done with their volume, they can delete the PVC, yes, objects from the API that allows reclamation of the resources, and then retain. The retain reclaim policy allows for manual reclamation of the resources. So what we can do, we can just delete the persistent volume associated with the storage, manually clean up the data, and manually delete associated storage, whatever we want. If you want to reuse that one, we can just retain that volume and use it. Delete, recycle, all these things. And here it is written how we can write it. It's a pod, right? It's a API version and kind is pod. It's a pod. If you see here, we have the volume mounts, which volume name is just given as vol. And here's the volume, where is the things that have been created. Okay, so let's see more in details. It's a very big one. So reserving the persistent volume claim. Here the kind is persistent volume claim. So if you are going to the user going to claim something, right? So when it is getting created, it providing the volume name for volume, for PV. Whatever is PVC created is given as for PV, right? So you'll understand more on this when we do the demo. Okay. Now lots of things are there, guys. It's now it's your turn your turn to just go there and just do practices. Okay, and here are the types of persistent volume. As I was saying that AWS Elastic block storage, EBS, to use the in that configurations file, you have different ways of using that one. AWS Elastic Block Store, Azure Disk, Azure File, Cinder, Flex Volume, GC Persistent Disk, Port Workspace, and vSphere Volume. These are the storage mechanics, storage systems you can go and use it. The following types of persistent volume are deprecated. This means that support is still available, but that we removed in future releases. So these are already being deprecated. Here is the new ones. Okay, these are the plugins which you can use here, new ones. So they keep upgrading their systems, right? Their tools. So you have to always follow their documentations to view. So here is the persistent volume. See how it is written. Capacity 5 GB, volume mode file system, local, right? Access mode, read, write once, policy claim recycle, storage class low, mount options hard, and these are things. So all these details you have to do. So if you are good enough in the, that's why I always tell, right, Kubernetes is not so easy that what you are thinking. It is like you have to do more practice and more exercises and more things if you want to be a master in Kubernetes. This require more knowledge and more things to do, and it's only can happen if you do practice. Okay, learn more and practice. So this is a very big document. Its access modes are there. See, these are the access modes what I just explained to you, right? And all details are there. Persistent volume claim, how you can claim it, right? Everything are there. See, so you can just go through this and see if we can get more ideas of this volume. Because if I just go through this persistent volume claim itself, it will take another 2 to 3 classes. Okay. Now, I pinged you in the WhatsApp, right? One project, whatever I have kept it this one. So whatever we have learned so far, all the objects, we are going to do all the demo, all the things in the final, this complete project. Everything I have kept it here. Everything I have kept it here. So let's see how we can use this, and let me explain you all these details. Okay, let me explain you all these details. So what we have here, let me just go open one file. Okay, what we have here, I have a file. It's called loginwebapp.war. This is a war file. That is means we have the Java application. This is the application file, and I need that the application file to be deployed into the pod. I need a deployment to be written. A definition file I have to write for the deployment. I need this deployment to happen. So what I have to do, I need to write the deployment definition file. Okay. So the project is something, we need a database, we need a front end, like the server, Tomcat server, because our application is a Java application, and now we need a server where I need to deploy this application. So what I'm going to do here, I'm going to create 2 pods. Okay, one will be our Tomcat pod deployment. 2 deployments I'm going to do. One will be Tomcat pod, another will be our MySQL database pod. Okay, so let me first go with this definition file. Okay, so if you see just the definition file here, what is given here, the API version apps v1. I already have told you how you'll get these API versions, right? From the documentations, right? From the documentations, you can always get the API versions. So for this pod, single pod, we have version v1. But for deployment, we have apps. We have apps slash v1. We have apps slash v1, right? Now, if I just, let's minimize this. Okay, if I just see here API version, okay, and here kind is deployment, I'm going to do it a deployment. Object type is the deployment, and the metadata, this name I have given as Tomcat Web namespace. So here everything I'm going to create under this dev namespace. Under this dev namespace. So if I have specified name as dev, then we have to create a dev namespace, right? For that, what we have to do, we have to write a namespace definition file. So the namespace definition file is given as dev. So here the API version is v1, kind is namespace, right? And name we have given as dev. So first we have to create the namespace and then we have to execute this definitions file, right? So if I just go here to the Tomcat here, so the labels, we have given those labels here, right? To identify what kind of applications it's Tomcat Web front end. This is the front end, and specifications we have all these template metadata we have, and labels also. See, this is pod label, right? This is deployment label. This is deployment label, and this is the pod label we have given here. And we have the container. Specific in the container, we have just used Tomcat Web, right? And here I've used Docker for Ranjit and login web app 11. So if I just go and search in the from where it will get it? It will get it from the Docker hub, right? Hub.docker. Let's see. Hub.docker.com. So this is available under this repository, Docker for Ranji and login web app colon 11, right? So if I just go and search here, let's copy that particular thing. As I have kept it public, anybody can download and use it, this image. This is nothing but the image, right? This is nothing but the image. So the image, container image, which image? I'm going to use this image, right? So let's search for this. What happens? Search. Okay, let's go to the range. Yeah. Let's go to this. I have 11 repositories. So what I need, login web app, right? Yes, this is login web app, right? Let's see whether we have 11 tag available or not. Go to the tags. Yeah, we have these 11 tags available. See, and this is the command you have to use it, right? So it will work. It could not able to find it, but it's still there, 11 tags there, right? Fine. So now what we can do here, let's go to that image and replicas. That means I'm going to create two deployment, two pods, right? Replicas will be there, two pods will be created. Selected type is the front end. So which is matching this replicas, this pods will match to the deployment front end labels, whatever we have given, right? The match labels front end. Now, similarly, if I go back to the MySQL DB, right? If you see here, we have the same thing revealed. Deployment, another deployment, namespace dev, and here labels I've created MySQL DB app name, and type I've given as backend. Same specifications you've written, but here we have written little more things available here. What is that? Under specifications, we have this container, and the image is given MySQL colon 11. Same thing, MySQL colon 11. That is the image which been created. Okay, now how this images gets created? I have the Docker files for that. See, these are the Docker files being used to create the image. So you can use this Docker file. I already have created those images and stored under the registry, right? So for your case, if you want to create and store in your registry and then work this, then you have to modify all the codes. First, create the image, build the image, okay, and put in your repository, and then modify the code based on that. For MySQL also, it's very simple. We have done this one. Okay. Now, let me explain this complete project, then we'll run it. Okay. What we'll do now? Okay, the MySQL DB I was explaining, right? The specifications here and the ports. Similarly for the Tomcat, right? Tomcat, we have given the front end. Here we have not specified any port. I'll show you where it is being specified. Okay. Now in definition file, MySQL div, we have this container port 3306. This is the default port of the MySQL. Here, what is this guy is used? Can anybody tell quickly?
Here we have used the config mapper.
And then
to store the DB password and user ID and password.
Yeah, both
in
config map and two objects been used, right? Both config map and secret.
Yeah.
Right? We have used secrets as well as config map. So as we are going to use this environment form config map and secret, then we must have to create the config map also, right? Config map and secret. So if I go here, we have this config map. See, API version v1 kind config map, right? And data. See, MySQL, my service host is MySQL DB service. So what is this MySQL service and DB service, and where I got it and how we have to write it? If you go to the definition file, here the name would be given my DB service. Here we have given the name as my DB service. One second. Config map, we have given a name as service host has given us MySQL DB service. That has to be used there. And here MySQL database we have given as DevOps class, right? And user we have given. Similarly, if we go to the secrets, right? See, encrypted format of the secrets is used. So we have to create like this API version v1 secret and all these things. Now, if I go to the MySQL DB again, here you can see after we use this one, the environment, this is the environment variable being used, right? Then we have used here the volumes. We have used the volumes. So remember, as I said, always we have to write the stateful sets for any deployment related to the database because it is being used with the storage system, right? So we have to here in the deployment also, we have simply, I have added mount points and the name of the persistent volume is given as MySQL persistent hyphen storage. So what it will do, it will first create a volume and mount the path. What is this path? This is the container pod path of the MySQL database. Okay, here the pod working directory. Now here the volumes I've used and then persistent volume. This is the volume mount we created and then we claimed this particular one. MySQL PV claim. And we have the replica, only one we are going to create. And the match selector is one, right? Similarly, if I go the persistent volume we created, now if I go and check the persistent volume, MySQL PV. Here,
sir, here.
Yeah.
Sir, here we have claimed the volume from our host machine or EBS volume.
This is host machine, local machine.
Okay.
I'll show you that one. This is the file. See, this is the persistent volume is created. So storage class name we have created local. See, labels we created local, and we have given a path of this host path like my systems, my laptop path, right? My laptop path here I've given /user and Kubernetes here. So here we have to little modify this. Okay, I'll show you how we'll do that. Now let's go to how you'll do that. Let's go to the let's see whether I have not started the server. So give me a few seconds. I'll just Okay, this time it seems the template I remodified the template and it is working this time. Okay, I just launched the system, right? But everything actually I think is installed. Let's see. Visitor get pod. So not connect. Maybe the Docker is not working. Let's see. System CTL start Docker. Authentication is required to start Docker. Sudo. We have to use sudo. Okay. Sudo. That's you. System. Start. Docker. Okay. Fail to start Docker is not able to start it. Docker service not found. Not sure it is installed properly or not. Let's come out from here. I'll quickly install. It did not work, I think. Let me quickly install it, okay? I should have created the script itself yesterday, but I forgot to do that. As we are already covered, this Kubernetes not required, but still I'll create the script for that. You can do that. It's very simple, right? You can create the script and keep it in your local machine. When you create the server, right? Just copy that to the server and execute that script. It will be done. Okay. So this is what you have to do. I'll show you that after this done, right? The cluster is off. I'll show you that example, the demo, how it works, and what is the what are the process you have to just create it. Again, for your understanding and to make you work, actually, I have just written everything, all the steps here. Okay, in the README file, if you go here below, I have written all the steps, what you have to do, right? Kubernetes demo project prerequisites, right? A Java application having Tomcat web server, MySQL database ports, using namespace, config map, secret, volume, service levels, all these details, right? First, you have to kubectl mini queue. So after this is done, you need to create this for image, right? The Docker file I was showing. So first you have to create the image. You have to store it. As I already have created the image and stored in my registry, I don't need this step. I can skip it. So after that, you have to create all these things, right? Namespace first. Create the namespace, dev namespace, and then config map, secret, then volume, then execute the deployment file, then execute the deployment file. This I need to modify. Here I have given replica set definition, but the file name is deployment definition, right? Deployment definition. Let me edit it. It is deployment definition. Where it is? I had created for replica set before, so that is still there. Deployment definition. Deployment definition. Good. Commit the changes. Right Now, if I just deployment definition, and then we can check the pod whether it is running or not. Everything I have written it here. See, all the details are there. Now, let's go ahead. Do all whatever is there in the project. Let's do that. Okay. Let's go to the things, and I need to clone this first to the machine. Let's clone this project. Okay. Our cluster is up and running now. So let's first clone it. Okay. What do you have to do? You just need to use Git, right? I'm not sure whether Git is installed. Yeah, Git is installed already. That's great. So you can just do Git clone. So it's a public repository. You can download to your machine as well, right? So let's go to the repo. So all the files are available here, right? All the files are available. So the DOM folder we have one. So what is this DOM folder contains? It contains the data what you want to insert into the database after the pod gets created. Okay, let me explain you that. If I just go to this, see DOM folder, we have one DOM file, DevOps class.sql, where it contains few records to insert it, right? Create. So it is just creating the user table. Then we can insert some data. User table. Okay. Now, how this will go there? So if I just go to the deployment file, you will see here definition file for MySQL DB, right? If you go there, you can see been used where it is. 1 second. Not in the deployment file. You'll find in the where is the PB MySQL PB. I'm showing you one place, right, where it was there. Yeah. So in the while building it, right, MySQL Docker file, MySQL. This is the file where see copy DOM file to the Docker daemon, right? So what it does, whenever we build the image, it will copy this DevOps class file to this one. That's why we need to build this image, right? We need to build this image. Now, let me modify a few things I was showing, right? What we need to modify it, if I just open the definition file, right? We need to, not definition file, I think my PV, right? Let's see, what is the PWT here? From Ubuntu. Let's go back to the Ubuntu. I need the one volume to be created, right? Let's do here, nothing is there. Okay, Minikube is done. Let me create one hidden folder, right? Hidden directory. It's called like my PV, my PV. Done. So what I need here, go back to the directory. Here I need to edit the volume, MySQL PV file. Okay, MySQL PV file. So here the path, whatever actually this path is nothing but my MacBook path. Okay, when I was doing the demo for the classes, I was directly doing from my MacBook. But as you know, the cluster Kubernetes cluster is heavy. It slowed down. I have that 8 GB of memory RAM, right? Still, it slowed down my machine. Okay, so that's why I'm not doing any installations. I didn't. I removed the Kubernetes from my laptop, so I'm using all the things in the AWS cloud. Now I need to modify this, right? So let's remove this particular path. I want this to be done. Searching. Sorry. So let's go to that directory here. What do we need? I modified it, everything, right? I have the application file, .war file. So first we need to create the namespace, right? Let's create the namespace. What is the command? Kubectl create -f, give the file name. Okay, give the file name. So namespace is created. If I do kubectl get ns, so we have the dev namespace 6 seconds ago created. Fine. So I was modifying the PV file, right? So okay, let me first modify this 9 PV. So here what we need this path to be changed, right? So what I need the path home Ubuntu. So I created a secret file directory, like a hidden directory. It's called .my PV, right? So I want this path to be my volume storage path, okay, locally in the system. Done. Let's save this one. So I just modified the file. Similarly, you have to, when you use this project, you have to modify lots of things as per your need, right? Now I created the namespace. Let's now create the MySQL service for config map and secrets. Config map and secrets, right? So let's use kubectl create kubectl create config map, right? Enter. So the config map is created. Similarly, we can create kubectl create and make sure all these things whatever you're creating should be under namespace dev, under dev namespace. Okay, let's create the secret should be also created under dev namespace, right? Let's see the file whether we have this under dev namespace or not. Yes, we have the dev space name. Now what do we need? We created the config map, we created the secret. Let's create the volume as well, and this volume we have to create. Let's do that. kubectl create -f, give the, see, volumes created as well as the claim also got created, as I have kept two things in this particular definition file. Okay, particular definition file. See, we can combine together and create one file also, one after another. So it will just create one by another. Okay, all those things, whatever file I have created, right? Everything you can put together in one file and just create it. It will get created. Okay, but segregating in different file, it will help in troubleshooting and it will give us a clear understanding on the development and approach how we are going to do that. That's why you have to segregate and keep it separate file for each objects, whatever you are creating, right? Now we have these things created. Now what we can do, I think this service MySQL also, okay. Now what we did, we created all the details, right? Also we have the service. I did not explain you the service one, right? We had the service file. So once we create the deployments, we need the service to be, the port to be exposed to the outside world so that we can use it, right? So we have this service UI, this service I have created for the UI, the front end. See, what is this service name? API version v1 service kind, and here type of service I'm using the node port. I'm using node port, and you have to specify the ports, the target port 8080, port 8080, and the node port I have given 30,008. We have given 30,008. Okay, so here node port I've given 30. Similarly, if I go back to the service MySQL part, here also we have this service. See, service MySQL DB service, right? MySQL DB service. That is the host name. That is the host name we have given in the definition file. here, and this should be created under the dev namespace. All the objects, whatever, it should be created under dev namespace. Otherwise, it will not work, right? The binding will not happen, right? If you create one in default, another in other, it will not work. So, and the port we are going to use here, and here I'm using cluster IP, right? Default IP, default service, because I don't need to expose the database to the externally outside world, right? I don't need the database to be exposed outside. That's why I use the cluster IP here. Okay, but in our case, in our UI case, UI service, it is exposed by the node port. The service name, we use the node port. So because we are going to use the UI part from the internet, right? So let's go there. So we have created all this. Now what we can do, we created what? We created the PV and PVC, right? If I just do kubectl get PV, so it gives us the PV details here. Okay, MySQL PV volume and 2 GB of storage and all these things. Okay, and it is named is under dev MySQL PV claim. The claim has done by it already being claimed, right? MySQL PV claim. Now, if I do kubectl get PVC, the claim. Sorry, what happened here? It's the PVC actually created under the namespace, right? So you have to give namespace equal to dev. So we have this PVC volume. Got this point, right? Fine. So you will be thinking, right, how the volume is kept, why the volume didn't keep in the dev namespace, why it is kept in the outside in the default namespace. Why, guys? See, sorry, it is also kept in dev namespace, but it is, even though you don't keep it, it will work, because what is the volume says, you can keep it in the same cluster anywhere. It's not equal any, because that we have to claim it. But if I just check this one, let's do a check. PV. So it's not there in the default namespace. Okay. If I just do namespace equal to dev. Yeah. Sorry, this is PVC. Right. Let's go to the PV. Yeah, the PV is there. Let's check if it is there. Why it is showing, guys? Can anybody tell? Wherever you check it, it is there. Any namespace it is available. Why? And how it is being, so claim is only visible to the dev namespace, but it is volume is visible to everywhere. That is why globally, because that is in the initially I told you in the definitions, right? Volume can be created by the administrator anywhere in the cluster. Okay, anywhere in the cluster. So here the status is already bound to this claim. The claim is already done. Written policy, reclaim policy is written. So now let's go there and check. So we have created volumes and everything. Let's go ahead and create the definitions for deployment. Let's create kubectl. Okay. You can just use apply here. I can have definition file here. Deployment created. Kubectl. Apply. F. Deployment. MySQL. So we have the pods created. So how many pods will be created, guys, now? How many pods will be there?
Sir, 2 for Tomcat and 1 for MySQL.
Okay. So we don't have anything now in the default namespace. So every time we have to specify the namespace here, right? So it's not, the short form is not working. So namespace equal to dev. See, we have 3 pods. We have 3 pods running. We have 3 pods running, right? So these are the 3 pods. 2 are for Tomcat, 2 are for Tomcat, and 1 is for MySQL DB. 1 is for MySQL DB, and other 2 are for Tomcat deployment, right? So this Tomcat deployment, we have 2 because we had given the replica as 2, right? We had given the replica as 2. That's why we have 2 replicas, 2 pods are running. Fine. Now we have these pods are running, but how will access these pods? How will access these pods? For that, we need the service to be created. We need the service to be created. So let's go ahead and create the service for each. So we can use kubectl, create -f service, right? Service.
Sir, is there any different between create and apply?
That's a good question. And okay, so the create, if you're going to create a definitions file first time, you are using a pod or any object first time, then you have to use create. If you are going to use apply, what will happen if you're modifying something for the existing pod, you modified the definitions file and then you have to apply it. What will do? It will delete the first pod and then apply it new definitions file. Even though if you have not used create and first time also, you can use apply, so it will check there is nothing there, then it will create it. That is the difference. Okay, you can apply. Normally what we do, if your pod is there and you have to modify something to the pod, then you have to use for this apply. Okay, you have to use apply. I'll show you that how we'll do. If you are just going to create, okay, now let me show you this example. Let me create the services and then I'll show you. So let's create the service. kubectl create -f service. So, here we have Tomcat service, UI, sorry. UI. Okay, both the service now created. Both the services created. Let's see. kubectl get services. So we have this. Okay, this is under default. So every time you have to specify namespace. So we have 2 now services here, and you can see here this port is forwarded to the 30,008. Now we can access this using this 30,008. For that, let's go ahead and get the IP address of the cluster of the node where the pods are running. So here in our case, it is the machine where the pod is running, right? So let's select this one, get this. Before that, remember before that, what we have used? We have used the port 30,008. We have forwarded the port. The port has been forwarded to 30,008. So this 30,008 should be whitelisted, right? In the security group. First, let's go and add into the security group here. Go to the security group. And you need to whitelist the 30,000 port, otherwise it will not work, right? In inbound sections, let's edit. Okay, we just have to add a rule. Let's add 30,008, correct? Now let's make it public because through internet we are going to access it, right? So save rules. Now 30,000 port is whitelisted. Now let's get the IP address and access the applications. So let's go to the instances. Here I can just get the IP address. Go here, give 30,008. Okay. Then application name is login web app. Hit enter. What is this application name? It should be login web app, I think, right? Yeah, login web app. Login web app, right? 30,008. Login web app. Why it is not working? Okay. Now see how we can do the troubleshoot here. We have the first check the services, right? Let's check the services. We have these two services available, right? Both the services available. And 8080 and 30,080 it is forwarded, and we have already whitelisted it, but still it is not working. Fine. Let's check the pod kubectl case pod pods namespace equal to dev, namespace equal to dev, and let's go inside the pod and check kubectl exit kubectl exit. One second. Exit, and similar to the container, you have to use it. Exit hyphen it, then pod name, right? Give the pod name. Suppose any one pod, let's go inside any one pod. Then you have to specify the namespace, right? You have namespace equal to dev. Okay. Okay. Now what happened? We entered inside the pod and we are under this web apps directory. We are under this web apps directory, right? So what you can do simply, see guys, they have updated their exec command now. So we can directly use kubectl exec and pod name, then it will work, right? Let me do that. Exec. What I can do, instead of using big command, you can use kubectl exec to go inside the pod. Okay, to go inside the pod. Let's get this pod. That's all. Then you have to use the command here bin pass. See what happens? Not found. kubectl get. Okay. Why it is giving not found, guys? I forgot to mention the namespace, right? So it found it searched, it tried searching in the default namespace. So what was we had used hyphen it, it should, you should give hyphen it itself. Okay. Now I connected inside, I went inside to the pod. Now I am inside the pod to the working directory, user local tomcat web app. Let's see whether our application is installed here or not. Yes, our application is here. Our application is here and it is deployed successfully, right? Inside the pod, this login web app is installed, right? Now what I can do here, just use this login web app, right? Let's go there and just refresh again. Why it is not working? 121.59 and 30,008 login web app. You can see the application is installed. Okay, so what I can do here now, let's see the pod and then what we have to do. Let's go inside kubectl get namespace equal to get. We should get namespace equal to no resources found under tab namespace. Okay. Oh, sorry. Okay, we have to write. So let's. Okay, so what we can do here. Let's describe this one first. kubectl describe. Okay. Describe service svc object name and hyphen namespace equal to a. Okay. So we have this node port 30,008, target port 8080, port is 8080. This is the IP of the pod. Okay. So this is the forwarded endpoint. This one. Okay. Now app is Tomcat web fronted node port single stack namespace is safe. Why it is not connecting? Services are running fine, right? And we have the ports running, services running. See, we have all this, everything is correct as for the things. Hey guys, maybe there's something which is missing or something which is preventing from the AWS EC2 instances to connect. That's why I'm not able to. Maybe some troubleshoot is required system level. Okay. When I was doing with my in my laptop with localhost, it was working perfectly. But thing is, from here it is not working. So let's do the troubleshoot. Let me do the troubleshoot and check if any issues there or anything I missed so that we can correct it. Maybe in our next class I'll show you the demo. So for you guys, what you do, whatever we have learned so far today, just do practice and try to do this. First install kubectl and minikube cluster in your machines, and then try to do whatever is given here. Try to modify all the things by your own. What are the things need to be modified? This image, whatever I have used it here, right? You can still use the same image. You can still use the same image and it will automatically download for you, right? So if I just go there and check the images, whether it is downloaded or not, if I just do Docker images, let's see. We don't have these images downloaded. Okay, fine. What we do here, either you can just use this particular Docker for ng MySQL, whatever it will download from my as it is public. If you are not going to use it, what you have to do, you have to simply build your own Docker file. Docker file is there. You know how to build the Docker file and create the image, right? So you can build your own, just clone it and build it. After building, I have given here the commands, right? How to build and everything in this one. Just build it image, keep it in the locally and use that Don't give the path, use that image name there itself. Whatever image name you want, you can create it, right? So you can use it. So try to do whatever is things, all the steps given here, and we'll see in the next class if it is working for you, it's fine, or else let me just fix it if there is any issues. I observed it, and then we'll see in that. That's all, guys. Do you have any questions or need to discuss anything?
Hello, sir.
Yeah.
Sir, suppose in the image section, here you have mentioned the tag is 11.
Yes.
Suppose we will write the latest inside in 11. We replace it latest. Then in the next, suppose we modify it in our code and build it. It will update in 12. In the Docker hub, and when we will kubectl -f apply the manifest file, then it will pull the latest, or it will show not modify.
No. It will pull the latest 12 one. If you want to get the 12 one, and you have to specify 12 there. Okay, let me show you that example, what I was showing you. Let's do the deployment part. Okay, deployment definition. Suppose let's do the Tomcat part, right? So here, suppose I'm using
latest
latest
instead of 11.
No. It will not get the latest one. You have to specify the tag. We don't have any latest available, right?
Every time we have to edit this tag.
No, remember, in the real time, in the organizations, we never use latest. We use the particular, we select that a particular tag or particular version of the image, right? We never use latest, remember. Always we have to use in the organizations. If you're doing the demo and practices, you are using latest version of that. And if you, even the latest version of also has some ID, one ID. If you have the tag latest, then you can download it without this one. So it will download it latest, okay? Normally latest, we don't provide it. You have to specify the tag. Suppose here, let's see, I downgraded it to 10. As I don't have 12 version, let's do it 10, okay? Again, web of 10. So I modified this file. What I have to do, I have to just simply use kubectl. Okay, before that, let's get pods namespace equal to dev. Namespace equal to 17 minutes ago it's created, right? Now, as I modified this file, let me reapply it, right? What I have to do, you have to do kubectl apply -f and the definition file of this Tomcat. See what it says? Configured, right? It is configured. Now, if I just check it here, it will have now just recreated, right? Let's check. See, 10 seconds or 15 seconds ago, it is recreated. It is recreated. Okay. Still not working. Some network issues since. Okay, fine. Now, this is how you have to modify, guys, and reconfigure. Now, what happened? Our pod using the downgraded version 10. If you have an updated version, whatever version, you have to specify and reapply it. That's all. Now you understood when to apply and when to use create, right?
Yes, sir.
Okay, guys, that's all for today's class. We can meet on the next class and we'll discuss whatever things the project we have left over, right? Try the project, whatever I just explained you at your home, and see if it is working for you. Okay. Chalo, guys. Bye-bye.